Okay, this is just a very brief walkthrough guide to the workshop today. Here are the the workshop challenges. Take a look at this. This is how you felt at the start of my lecture on Monday. I forgot to ask how you felt afterwards. Click this link, let me know. You can see that lecture at this link. It's already been uploaded to Vital as well. You can also access the project files that I was working on during the lecture at this link here. Today, I hope you're going to be able to put everything I went through in the lecture on Friday into practice and reproduce it at least. And we're going to work through these challenges beyond that. So I definitely recommend you sing along to what I did on Friday first. Make sure you're comfortable with that. Make sure you get the same plots and the same result to your t-tests, and then start these challenges. Okay, I'm just going to whiz through this. So this is challenge 1, and the first task is, again, I'm just going to do this again just so you can do it. So you should have created an R project, and this is the file I was working on Monday with a few extra comments. You can get that now. I've started a new R script file called challenge_R1. I'm just going to do exactly what I did at the start of the last lecture and read in that data file. Read in rom.csv file. Well, that was the comment. So remember, the file was called, let's call it math. It was read.csv. There's the file name. Oops, no. There you go, and it was semicolon separated. Okay, so do that. There it is. I'm not going to click it. I wanted to subset that to remove all of the records that were associated with a G3 test score 0, and I defined a variable called math underscore no 0 in the G3, and I did that using the which function and made this statement. So I'm going to call math again, call G3, and I'm going to say greater than 0. Remember, you've got to put the comment in after that. Made a mistake already. I need a square bracket here when I'm filtering. Okay, done. Okay, I can check that very quickly just by going hist math. Always do that. You just select the G3 column. Okay, done that every single time so far. Right, there you go. Proper label, proper titles, please. Okay, so I've done task 1.1. Let's just let's just do this on the fly, right? Task 1.1. Do comment your code. Make sure you're able to go back and read it later. The temptation is, I know, just to whiz through this, but make sure it's legible for you later when you're actually trying to learn how to do this again, because you're going to forget. So that was task 1.1. Task 2.2 is generate box plots that show the G3 scores with respect to the student weekly alcohol consumption. So it's another variable within that data set, which is actually called WALC, which refers to the rating that each student gave themselves for their weekly alcohol intake on a range of 1 to 5, 1 being low, 5 being high. So we can generate a box plot. So let me write task 1.2, and that's pretty straightforward. Box plot. I'm looking at the G3 scores again versus the weekly alcohol consumption, and I'm going to use my data on the no zeros again. Okay, I might want to give it a few labels. I'm going to call this X label equals weekly alcohol intake rating 1 to 5. And also going to label the y-axis with G3 test scores. And should do a proper job, shouldn't I? Let's give it a title as well. Main equals G3 test scores with respect to weekly alcohol intake. Okay, think of something. I'm sure you can think of something better than that, right? Let's just do that. There you go. It's all in there. My title's so long it's off the page. I'm not going to worry about that. Okay. Now that was task 1.2. Yep. Brilliant. You should see 5 box plots. Yes, I do. Task 1.3, based on weekly alcohol consumption, divide the students into 2 groups. For example, students who rated their consumption greater than or equal to 3 and students who rated their consumption at less than 2. Hint, use the which function again. Okay, so we should be pretty used to this now, and use descriptive variable names. Let's do that. So rather than have 5 separate groups here based on those ratings, I'm going to actually combine these 3 into a single group. So everything that was greater than or equal to 3, and combine these 2 into everything less than 3. So I've got these 2 groups, and I'm going to compare those 2 groups. Okay. This is task 1.3. Let's call it G3. What did I suggest here? Yeah. WAlc low. Let's call that math no 0 square bracket which open bracket math no 0 alc, and here's my condition, greater than less than 3. Yep, that's the first one. Done that one. And you can see I've actually got another data frame here. Actually, I'm going to save myself a bit of time, and I'm just going to get a column into that variable rather than the whole data frame. So I'm going to do a $G3 after that. Okay. Control and enter. G3, well, high math no 0, which math no 0. Again, weekly alcohol is the variable, and this time greater than or equal to 3. Close that parenthesis, comma, G3. Okay, there's my second one. Right, so I think I've done that now. Yep, I did that. That was task 1.3. Task 1.4, determine the descriptive statistics for these groups. That is the mean, median, interquartile ranges, standard deviation. Okay, so there is a function I can use in a package called psych. So let's just check you got that package installed. I have, because I've already searched for it. So if you go to the packages tab in your window here and type PSYH, right, you'll be able to select that if it's not already selected, and our studio will include that in your project. Now, to use that package, you can't just type psych or type a function from that package. You have to do the command. Hang on, let's just correct that for a start. This is task 1.4 now. I have to do library psych, okay, and you can see it popped up there, look. And I'm going to do describe, okay, G3 weekly alc, and let's describe the low first. There you go, and in my console it spits out the number of variables I'm looking at. In this case, it's just the one. Number of values in that list, the mean value of values in that list, and the standard deviation, the median, and min, max, range, and a few other things here that I don't really care about. Do the same for your high group. And you can see here quite a big difference between the means. This is 12.03 for the G3 test scores that rated the intake at less than 3 per week, and we're a good point lower in the mean for those who rated it higher than 3 or equal to 3. Right, so that was task 1.4. Task 1.5. What was that? Generate histograms for each of the two groups and overlay them on the same plot. Now, I wanted to get around to this in the lecture last week, just to get you doing a bit more plotting and visualization. But I didn't get time, so I'm going to do that now. This is a bit more involved, so stay with me. Now, you know how to do a histogram for both of these. It's just hist G3. Okay, it's that simple. Right, now, I want to do something a bit different here. I want to plot both the histograms for the low group and the high group on the same plot and overlap them. Okay, so I can directly compare the distributions of test scores with respect to each of those groups. Now, to do that, I am going to actually, rather than just plot that, I'm going to create a variable and assign that plot to the variable. Okay, it's just an object. H2 hist G3 high. Okay, now they are just going to sit in those variables for the time being. I'm actually going to do that one as well. It will plot it again. What I'm going to do now is I'm going to define some colors that I'm going to use for each of these histograms, because a bit of color isn't bad. Let's do color 1, and the way we define a color in R, I always use RGB, and I'm going to call now RGB takes 4 values. Obviously, you got your red, your green, and your blue. So if I do 1, 0, 0, it's going to be red, and the fourth one is the opacity or the transparentness of that. I'm going to use a value of 0.3, and then I'm also going to define a second color, RGB, and this time I'm going to keep the red at 0 and keep and put the green to 1. Blue can stay at 0, and again 0.3. Okay, so to find those colors. Now, I am going to now create another plot. Okay, I'm just going to call the function plot, and what that's going to do is give me a sort of canvas to add these histograms to. Now I'm going to add the H1 first. Okay, and that's all I'm going to do for now. And then, if I do that, I don't think I click Control and Enter on that. There you go, plot 1. And I'm also going to do col equals color 1. Okay, and it's red, brilliant. I'm also going to call plot again. This time I'm going to call H2 and color equals col 2. Okay, now you can see that is already completely overwritten that plot. So if I want to plot the first one again, I got to go back and run Control and Enter on that. This time, if I add the parameter, I forgot what it is. Add equals T. There you go. It will overlay the second one onto the first. Okay. Actually, that's quite nice. I can really see the differences in these two distributions. So the mint green color is actually the high group, and the pinkish red color is the low group, and the darkest green is sort of what's left is the overlap of those two. So you can see the high group is here, and the low group's test scores are considerably skewed to the right with respect to the high group. Okay, now I've got a bit of work to do here. This isn't a perfect graph. I've got to include, let's include, I'm just going to do main. I'm really lazy today, so I'm going to do main equals nothing. I'm going to do x label equals G3. Okay, and I'm going to leave frequency as it is. Okay, and if I run that and I run the next line again, that's a bit better. Now, what this graph is really missing, I can see actually this needs to be a bit higher as well. So I'm going to change the y limits on my y-axis, and I'm going to say, let's do a vector from 0 to 50. That's a bit better, isn't it? Okay, I would also like a legend on here somewhere. That's pretty straightforward to do. I'm just going to go legend, right? And the first parameter in my legend function is going to be a positional variable, which is a string, and it's going to be top right. In this case, you can go bottom left, bottom right. I'm going to call that. The next thing I'm going to do is I'm going to call, I'm going to actually give labels to my legend elements. I can do that using a vector of the form. I'm going to do weekly alc. The first one is the low group is less than 3, and then weekly alc, oops, make them strings, is greater than or equal to 3. And the last thing I'm going to do here is I'm going to give them, make sure they have the colors. Okay, so with the legend I use the parameter called fill, and again I can just give it a vector, and I'm going to call color 1 and color 2 there. Do all that, there you go, it'll give me a legend. Right, that was task 1.5. Task 1.6, okay. Postulate a null hypothesis that considers the difference in the mean G3 test scores between the two groups. Check that both groups adhere to a normal distribution. Just going to change that a sec. And perform an independent t-test. Decide whether we're going to do that. Okay, so we did this. This is the last thing we did in the lecture on Friday. So you should be happy with this. Task 1.6. So I've got those two groups. Let's check that they're normal. Shapiro test. Oops. I'm going to use G3 walk low. Okay. Looks good to me. If it's anything bigger than 0.1, I can't consider it to be a normal distribution. G3 walk high. And again, for the high group as well, much lower than 0.1. So we're good. We can do a t-test. Easy peasy. T.test. Let's put G3 low, G3 high, and run that. Okay, I've got a p-value of 0.00045. Okay, so it's considerably less than 0.05, which means, so if you'd made the hypothesis that there was no difference in the means in G3 test scores between students who who rated their alcohol intake equal to or above 3 or less than 3, then you would be rejecting that hypothesis. Okay, there is a significant difference in the means between those two groups. Right, I hope you're able to follow along, and we'll see how we get on tomorrow. Okay.